Zoom meeting, share screen, this one, share, go full screen, and more. Why don't I get hide floating meeting controls? Okay. Finally, are we live on YouTube, anybody? I don't know. I just hope, okay, I'll have to be somewhere here. Okay, so this is very informal, right? So basically, since you guys said speak about something, I'll talk about the physics Nobel Prizes. This is mostly a talk in history. It's a quiz more than a talk, but just some interesting tidbits. Okay, so firstly, any day is always a good time to talk about science. Today especially so. It's the birthday of Michelson. Okay, Michelson of speed of light and Michelson-Morley experiment. Michelson founded two physics departments in the US. Okay, one was at the University of Chicago. The other one was at a smaller university where he was associated for most of his life. Any idea what that is? Either the old name, it's got a new name now. Old name is Case Institute of Applied Science, which is now Case Western Reserve University, physics department founded by Michelson. It's also the birthday of this lady who is not very famous, but she wrote lots of letters to her then boyfriend, later husband, who apparently did not include her name in publications, but is very famous and got Nobel Prizes. After which, the government of Serbia decided to buy all her correspondence with her boyfriend slash husband. So who is this? The person's husband is obviously way, way, way more famous. So if you had to guess a physicist, that would be the person. This is Mileva Maric Einstein. Okay. First wife. Okay. Who was basically a maths person who helped apparently with a lot of the initial things in 1905 or before that. It's also the birthday of Eric Cornell, who got the Nobel Prize for Bose-Einstein condensation and laser cooling. It's also the death anniversary of Paul Langevin, magnetism, right? By the way, he spent a lot of time during the war. He had to leave. He went to the UK and actually worked on submarine detection during the war effort. And it's also the death anniversary of Robert Millikan, who, apart from playing with oil drops, he was a president of Caltech University for a long time and actually made Caltech into a hardcore physics university. And in 1932, he was on the committee to organize the 1932 Olympics in Los Angeles. He was also a sportsman. Okay, so interesting characters. At least you have 3 Nobel laureates in this, physics Nobel laureates in this itself. But anyway, you know about the Nobel Prize. These are the world's most prestigious awards set up by Alfred Nobel in 5 original categories. And remember, in science, it's awarded to individuals. Peace can be awarded to institutions, but science is awarded to individuals. And apparently what he said is transformative discoveries, which benefit mankind and all that stuff. So now, of course, let's look at the medal, since you've probably not looked at it. The medal, one side of it, which is called the obverse side, or the front side, is the same for all subjects, science subjects. It's got the profile of Alfred Nobel. The back side is the same for physics and chemistry. It has the goddess of nature, Isis, who's emerging from the clouds, holding a cornucopia, the horn of plenty, and the genius of science is lifting her veil. Okay, and there are nature's inscription improved human life through discovered arts, which is adapted from Virgil's poem called the Aeneid. And the second line says that it's the Latin version of the Royal Swedish Academy of Sciences. And the third thing which is inscribed there is the recipient's name. Now, this guy is, you can see in fine print, the name is J. Eric Lindbergh. He's the guy who made the medal. So this was the first medal and he put his own name on it, just as a benchmarking thing. You'd also get a fancy diploma, which is this, made especially for every laureate separately. You get some money. Currently, it's 11 million kroner, which has been in inflation adjusted terms about the same through history. And you, of course, become very famous. And now there are interesting statistics. Are you doing something with your phone? Okay. Of course, who gets the Nobel Prizes? Right now, of course, the US dominates over everybody else by a huge margin. But it's more interesting to look at historically. The early prizes are dominated by Germany, France, etc. And then USA picks up, and USA is now the major chunk of it. It just shows you where the cutting edge research in the world is happening. There are also, I mean, lots of statistics of the Nobel Prize. This Nobel Prize is analyzed to death. You can look at all kinds of statistics you want. Per person, per capita, who has more Nobel Prizes, etc. etc. A lot of analysis is done. What happens to the rate of winning Nobel Prizes? Is it going down, up, whatever else? And of course, there is a gender gap. If you see, this is all Nobel Prizes. The green is the total. The blue is or green is male, blue is female, and physics is particularly bad. Of course, there are efforts to improve it. I mean, they are, I think, really trying to get women in these things. So in the last decade, it has been much higher. And you'll see some of these physics people, I think. Okay, so we're going to look at various things today, some achievements, how they are given, some omissions, some controversies, etc., etc. So here, first quiz. I couldn't get chocolates from the... Here are the first Nobel laureates of their countries. Okay, C.V. Raman, no prizes. Okay, 1979. Who is this? First physics Nobel laureate from Pakistan. This is Abdus Salam. 1933. First Nobel laureate from Austria.
Very familiar.
Quantum mechanics बोल दिया चलो अभी और क्या बचा है Schrödinger. Okay, 1958 Russia. The first USSR Nobel laureate is 1958. It took a long time, but he went faster than light. If that's a clue. Cherenkov. Absolutely. Okay. All right. Now, I tried to look at it. This is my random take of what kind of things won the prize. So the first part is the early quantum revolution, the fundamental discoveries, Planck, Einstein, Bohr, etc. Then you have when quantum mechanics is really getting set up, and nuclear physics is emerging. So you have Schrödinger, Heisenberg, Fermi. 50s and 60s, you've come to the semiconductor era, lasers, your Shockley, Towns. Then you have superconductivity, gauge theories, particle acceleration coming, and then particle physics starts winning lots of Nobel Prizes. 1970s, 80s, 90s, 2000, you have a lot of astronomy and particle physics breakthroughs. And then now it seems to be a mixed bag. Everything from quantum information to lasers to planets to gravitational waves, whole mix. Okay, again, you have the 1901 is the first Nobel laureate, that's Roentgen. Physics Nobel laureate is Roentgen. 1909, the first Italian. This is almost an engineering, was said like this. Physics ki tarah, this is almost an engineering prize, was the comment. 1909, they were awarded to two people. The other guy is Carl Ferdinand Braun. The only reason I know because I worked at the Ferdinand Braun Institute and he discovered the CRO, the cathode ray oscilloscope. But this guy did something else, Italian. And people said, yeah, this is not physics, this is engineering. And there was a claim that somebody from India should have got it long time back. This is Marconi. This is Marconi radio something. The first Japanese, 49. Yukawa. And the first person from Belgium, 2013. Again, two people got the prize. The first one is the guy after whom the thing is named, but this was thanks to thousands of people working on it that they discovered this. But they gave the two people the prize, Higgs and Francois Angler or whatever, however it's pronounced. So Belgium had to wait for a long time. So again, what kind of areas get the prize? Again, my random ordering. You can have key theoretical breakthrough, challenging lab results, accelerator-based physics, particle physics gets a lot of them. Challenging observational results in astronomy or cosmology, that gets a lot something. Sophisticated instrumentation development. And sometimes you have simple but landmark discoveries benefiting humankind, which I think are the real ones that are part of what Nobel thought their prizes are for. How many women have got it? 5. we leave Curie out. By the way, Langevin, I forgot to tell you, also had apparently an affair with Marie Curie after Pierre Curie passed away. He had affairs with a lot of people. Big list of things. Okay. 4 other women have won the Nobel Prize. It took a very long time after Curie. The next prize is 1963 to somebody who worked in nuclear physics. But the reason in the 1930s, the reason the prize took so long is because the model could not be validated until lasers came up. Okay. And today her work is most relevant in optics, especially in nonlinear optics. And her name is the name of the unit of 2-photon absorption. This is Maria Goeppert-Mayer. Following that, of course, we've had 3 in recent years. 2018, 2023, any guesses? These are new ones. Now there's a fire alarm and we need to leave. No. Okay. 20 is exoplanets. Andrea's guess.
2020 is black hole.
2020 is Andrea guess. Yeah, the black hole at the center of the galaxy, along with exoplanets. Yes. 2023 is Anne Hulier. 2018 is Donna Strickland. Lasers. Both. Okay. So how does this happen? Nominations are sent to 3,000 people. Jan to Feb. The committee reviews about 250 to 300 of them between March to July. Reports are prepared. Something confidential is 50 years. So we don't know the Nobel Prizes nominations till about 50 years back, but that itself is quite interesting. You'll see. And selection criteria are originality, scientific impact, tested by time principle. As you will see, many people have lost out because of that. And the fact that discovery should be proven, should not just be a idea. Final vote, Swedish Academy of Sciences votes in September, October. Press conference is the first week of October, and then the award ceremony is on 10th of December. Okay. And that's what I prepared this talk for. I had to give it to somewhere. So let's see. I think the birth of modern physics, the first era. There are 2 I'd like to highlight. X-rays. Röntgen. He discovers this thing, and that revolutionized both medicine and research. And radioactivity. The Curies and Becquerel. Of course, this opens up the door to many things. And again, the 2 pictures you see. The top one is what is photo 51, the discovery which proved that DNA was a double helix. And the bottom one, so that's X-ray diffraction again, X-rays being used. The bottom one is again X-ray diffraction, but not from Earth. This is X-ray diffraction on Mars. The 2 rovers on Mars carry X-ray spectrometers on them to do elemental analysis of the soil. So X-ray diffraction has become a standard technique now for many things. And this gave rise to many other prizes. So 1914, you got Max von Laue gets a prize for Laue diffraction. 1915, father and son Bragg get it for X-ray crystallography and Bragg's law. 1924, Siegbahn gets it for X-ray spectroscopy. Many chemistry prizes are related to X-rays. 1962, X-ray crystallography of hemoglobin. 1964 is vitamin B12. 1985 is development of X-ray techniques for molecules. And 2009 is Wenke and others for the X-ray crystallography studies on the ribosome. So X-rays have given rise to several Nobel Prizes. Okay. Then I think it's the quantum revolution that comes next. Planck in 1918. Einstein in 21 gets it for the photoelectric effect. Okay, we'll talk about this in a bit. Bohr, of course, for his model of the atom. Heisenberg for uncertainty. Schrödinger for wave mechanics. And this is, of course, the foundation of everything. Now, just to give you an idea, Nobel lectures were very different. And I will read this out because it's a breathless statement and only a German could have written this. Okay. So, if I take it correctly that the duty imposed upon me today is to give a public lecture on my writings, then I believe that this task, the importance of which I am well aware through the gratitude felt towards a noble-minded founder of our foundation, cannot be more suitably fulfilled by my trying to give you the story of the origin of the quantum theory in broad outlines, and to couple with this a picture in a small frame of the development of the theory up to now and its present-day significance for physics. That's the first line of Planck. Right? This could have only been thought by somebody in German and then translated. Okay. Of course, quantum has got prizes in other subjects. Molecular orbital theory in 1966 in chemistry, quantum mechanics based reactivity predictions in 81. DFT gets a prize for computational chemistry is 1998, and multi-scale modeling right is in 2013. So chemistry gets a lot of things for using quantum mechanics there. Uh, you next come to nuclear and particle physics, starting off with Rutherford in 1908. Alpha particle scattering, his experiment. Chadwick discovers a neutron. Anderson discovers a positron. And here is the paper of Chadwick's neutron thing. And what he has is a polonium source hitting a beryllium target. Right now, every neutron source, ones in TF are also americium polonium, AMPO, right? We have americium hitting polonium, generating, americium hitting beryllium, ambi, generating neutrons. And that is, of course, Fermi's first reactor. So then, of course, Powell discovers mesons, giving you new subatomic particles, and this then impacts everything else. Uh, of course, I am, guys know I'm a laser guy, I'm a semiconductor guy, so I'm a little biased to this. The transistor, of course, changes the world. And with the modern electronics, you wouldn't have without this. The lasers also being able to amplify light changes the world. Semiconductor heterostructures, if you ask me, recognize very too late, Alfrov and Kromer, which make lasers a reality, semiconductor lasers everywhere at room temperature. The integrated circuit also is very late. It's Kilby in 2000. Fiber optics, without which you wouldn't have any internet and communication and things like that. Kilby gets it in 2009. That's the middle picture. Same year, it was also given to the CCD. And then blue and white LEDs get it in that should be 2014. Amano Akasaki and Nakamura. Of course, all these things are transformed on this. Okay. Now, sometimes you really wonder, isko Nobel kaise mila? Right? I mean, how simple can something be? These days the work done is really, sort of cutting edge and something. But just look at this particular Nobel Prize, which has been it was in the limelight right that time itself. Isko kaise diya? Aur kisi ko mila nahi kya? This is a physics Nobel. At the time, you can look at the time frame and see who are these guys. 1912. So this is when the Rutherfords and those guys are getting their prizes. This is Gustav Dalin. Gustav Dalin gets a prize for the invention of an automatic regulator for gas accumulators in illuminating lighthouses and booths. Okay. So in those days, you had gas-powered lighthouses, right? Where if you want to keep the flame constant, you have to somehow adjust the thing. It's a flotation device. In my mind, this would be a master's project. Okay. But the thing what happened is maybe while doing these experiments with acetylene and he was trying to store acetylene in something safely, etc., there was an explosion and he lost his eyesight, etc., because acid, explosion, dynamite, this, that, maybe Swedish committee decided, chalo, consolation prize, but we don't know. But this guy became more famous because he invented something else. This company in Sweden called AGA, gas company, AGA, right? And this material called agamasan to store acetylene. But more importantly, he invented the cooking range. Okay, so this is the first sort of hot plate kind of a cooking range. You have gas burners on top here and the oven below. This cooking range was the most popular cooking range in the world, and they hired somebody to advertise it, who changed the field of advertising. He starts his career here. His name is Ogilvy. So Ogilvy starts his career by advertising cooking ranges for this guy. Okay, very interesting stories. Now, some of the misses. So Einstein got it for photoelectric effect, and he was pissed. He didn't get it for relativity. He gave his Nobel lecture on relativity. Okay, his Nobel lecture is actually titled "Fundamental Ideas and Problems in the Theory of Relativity." Now, why not for relativity? Because in those days it was not proven. Right now we know how to prove it, etc. And they applied this tested by time criterion, and some of the members were skeptical of these theoretical predictions, and it seemed very speculative. So at least in those days, you had to have experimental validation. I don't think that's very true now, but anyway. Okay, then Lisa Meitner doesn't get it. So there is an experimental finding by Otto Hahn and Fritz Strassmann that if you bombard uranium with neutrons, you get barium. And this is fission. They can't explain it. Lisa Meitner and Otto Frisch, her nephew, they explained it theoretically in the same year, within a few months. Okay. The 1994 chemistry prize is given only to Hahn, neither to Meitner nor Frisch. And she was Jewish. She had to flee Germany. And you can't have more than 3, so they couldn't have given everybody. And in general, there's a bias towards women in those days. So, of course, fission is key. And the amazing thing is now that the records, except the last 50 years, are released. Lisa Meitner was nominated 19 times for the physics prize and 19 times the chemistry prize and 30 times for the physics prize and didn't win. Okay. So, I mean, the awards also reflect not just science, but social biases as well. That's all you can say. Then you have Rosalind Franklin, double helix structure, thanks to photo 51, which I showed you. And Watson, Crick, and Wilkins get the Nobel Prize in Physiology of Medicine for discovering the double helix structure, which is entirely based on the work of Franklin and Gosling. In fact, they had a thing. They announced, it is with great regret that we have to announce a death on Friday, 18 July 1952 of the DNA helix. Death followed a protracted illness during intensive Besselized injections because they were using Bessel functions. Failed to relieve a memorial service, and it is hoped that Wilkins will speak. Franklin and Gosling signed this. They had put up this thing because they're very sure it's a double helix now. So the single helix is dead. So, but she didn't get it. Why? Because she died. She died very young. She died in 1958. The prize is awarded in 1962. No posthumous prizes. And again, Wilkins, Watson and Crick just did not give her credit. There are several others. Jocelyn Bell Burnell, her data for pulsars. I mean, she didn't get it. Her advisor gets it. Vera Rubin, who basically gave us evidence for dark matter through galaxy rotation, which was this year's IOA question, actually. But I think at least they have been honored. Jocelyn Bell Burnell got the Breakthrough Prize, and she donated all of it to fund students. Okay. And Vera Rubin obviously now has an observatory named after her, and also a recent US quarter, which I have not laid my hands on as yet, is minted. The recent US quarter has Vera Rubin on it. So, okay. Controversies about the Nobel Prize. There are so many that there's a whole web page devoted to. There's an entire Wikipedia page on Nobel Prize in Physics controversies. Please look at this. Okay. Now, it's a matter of timing and luck, right? Because the committees change, the technological readiness. I mean, some things you can verify very easily. Some you have to wait for 50 years. Geopolitical events, Cold War, etc. Russians published in journals that nobody read, so they didn't know about it. Things like that have happened. A lot of people working on it. The first guy who went to publish it is the one who's known about it. And then you must live long enough that your discovery finally gets impacted, but you must not die. Right. So there is a age thing as well. And so, for example, Chandrasekhar had to wait 50 years to get recognition for black holes. Right. Kilby, he developed the IC in 1958 and got the prize in 2000. Okay. Rines and Cohen's neutrino experiment was done in 1956, Nobel Prize 1995. So there have been huge things, but then graphene got it within a year, and it's still not there anywhere. So luck, timing, political influence, everything matters. Let's see Indians who are nominated. Okay, so here is a letter that is nominating Professor Bhabha of Bombay for studies of radiations cosmics. Who's nominating him? Let's see his signature. This is Hadamard, mathematician. Now, this guy sent a postcard saying I'm nominating Bhabha. That's all he did. When Raman was nominated, they sent a 100-page plus dossier with every paper he had written and a detailed something saying, okay, he has done something. All this. This guy just sent a postcard saying I'm nominating Raman. Mathematician. Okay. So, the person with the maximum nominations is actually S.N. Bose. S.N. Bose is nominated in 1956, 59, 62, 68, continuously almost till 74. Meghnad Saha is nominated also a few times in the 1930s and late 30s, 40s, even in the 50s. The only other person who got a nomination is E.C.G. Sudarshan in 74. So these are, I mean, of course, this is right now we know the results only till 20, yeah, till 75, basically. 74 is the last one. We will know later if there are any other Indians, but the 50-year embargo says that till 1974, these are the Indians who have been nominated. Okay. There are limitations. I think the Nobel doesn't recognize the collaborative nature of modern science. It's very rare that, one person makes a breakthrough or even only three people can share it. So LIGO, for example, Weissner, Thorne, and Barrett, they got it, but thousands contributed. Similarly, for the Higgs, Peter Higgs and Francois Anglet get it, but a lot of very critical contributions were overlooked. Pulsars, again, the discovery team members, that is Jocelyn Bell Burnell, didn't get it.
Even the 2011 supernova.
Yeah, so many. Then the geographic distribution is, of course, concentrated in wealthy nations because, before you ask me why doesn't we win Nobel Prizes and all, expensive equipment and facilities for research is concentrated in those countries. Journals are dominated in English, so people from non-English speaking countries often can get left out. And the best scientists from developing nations move to those other places to work. So even if they get it, they are there. And what happens after the Nobel, right? So there is this famous Nobel disease, but some of them actually do reasonably well. So the Pugwash conferences for nuclear disarmament were started by, this starts from the Einstein-Russell manifesto itself. So there are a lot of Nobel laureates associated with the Pugwash conference, physics Nobel Prizes winners. Then Carl Wyman, he gets into science education and starts PhET simulations, which anybody in physics today education would know. Some people get into public science roles or give testimony. Richard Feynman, about the space shuttle disaster, becomes an expert in giving testimony. Stephen Weinberg became the Secretary of Energy or something. He played a role in government, basically. No, Stephen Chu was Energy Secretary. Stephen Weinberg was he took up to public communication of science. And some of them go crazy. Okay, so Shockley, for example, Shockley went mad, totally mad. I mean, which is why actually people left it, formed Fairfield Semiconductors, and then from there people left and formed Intel and whatever. A lot of it is because Shockley just went mad. He was advocating eugenics, selective breeding, sterilization, autonomous robots to kill off people. I mean, he just went totally crazy. But even before that, Philip Leonard Jones' potential and all, he became a Nazi supporter. He promoted Aryan physics. He rejected relativity because it was Jewish science, etc. And he was very promoted with a lot of racist theory. So you have people who can go nuts after winning the Nobel. So takes a world. And what's going on? This is an old talk. Now that can the traditional physics, chemistry, physiology, medicine categories take care of it? You've seen that many discoveries have been interdisciplinary. There are several prizes which people have said are engineering, not physics. 2024, it was essentially machine learning with artificial neural networks, etc. Then you have the consolation prize of Dallin. So if you would benefit to humankind, what would you do if you had people working in climate science or sustainable technology, etc., who don't fit in any of these categories? And how do you weigh fundamental discovery versus applied benefit? And hence now there are other competing big money awards. So remember, the Nobel Prize at 11 million kroner is about 1.1 million US. The breakthrough prize in fundamental physics is 3 million US per person, maximum 3 people. Kavli Prize in astronomy and nanoscience is 1 million. The Shaw Prize in maths and astronomy is 1.2 million. The Tang Prize is 50 million new Taiwan dollars, which is 1.63 million. But the advantage is you can use the money for research. There's a component for research. And many of these people actually prefer getting money for research than just for themselves. So there are competitors now. And I think I'll stop there. Here is a quiz. Again, I'm not putting the years. I will put that if you ask me for a hint. What is common to these sets of people? Or all physics Nobel laureates? If you want a hint, I'll put up the years. I'll put up the years. So this actually also makes for a very good probability question. Okay, so these are the 4 pairs of father-son Nobel laureates in physics. The giveaway is 1915, which is Bragg and Bragg, father and son. Then you have Niels Bohr and Age Bohr. You have J.J. Thomson, cathode rays, and George Fagey Thomson. And you have Kai Siegban and Murray Siegban. Okay, so if you look at the odds of winning a Nobel Prize, how many people are there? How many people do physics? Let's assume how many people do a PhD in physics. How many people do research? Okay, the probability is of winning a Nobel Prize versus the fact that out of the people, so if you have won a Nobel Prize, the chance that your son or relative or somebody wins a Nobel Prize is very high, much higher than what you would predict otherwise. So anyway, I'll just stop here. I think. Thank you. This is something. So what we can do is we can check if there is anybody. So there are some people online. If you have a question, just please unmute and ask is what I would say. Oh, but I can't hear you. No, I can hear you. I'm unmuted.
2011.
One sec. What I should do is I should go to YouTube and what did we do? Anyway, it's meant to save the video.